In this lesson, we're going to talk about the discriminant and also about equations that can be written in quadratic form. First, let's talk about the discriminant. The definition says that for a quadratic equation of the form ax squared plus bx plus c equals 0, with rational number coefficients and a not equal to 0, the expression b squared minus 4ac is called the discriminant, and it can be used to determine the number and type of the solutions of the equation. So I'm sure you recognize this expression. This expression is the radicand of the quadratic formula. So if you remember the quadratic formula, it says x is negative b plus or minus square root of b squared minus 4ac all over 2 times a. So you notice b squared minus 4ac is right there. So just the value of that number is going to tell us the type of solutions that we are going to have for our equation and how many. So our chart here says that if the discriminant b squared minus 4ac is positive, then we'll get two different real number solutions. And you can see that because let's just make up some numbers here. Let's say I ended up with a negative 7 plus or minus square root of something over 16. Okay, just making something up here. If this is a positive number, then we'll have plus the square root of that and minus the square root of that added to the negative 7 and divided by 16. So that's going to give you two different solutions, but also if it's positive, taking the square root means you'll have real numbers. Now if the discriminant, the thing under the square root, is a 0, then doesn't that do away with all of this part of the quadratic formula? So we end up with just negative 7/16 in this case. So we would have one solution. It's actually a repeated solution, and it will be a rational number, a number that is able to be expressed in fraction form. If the number under here is negative, you remember we take the square root of a negative, you'll get imaginary numbers. But not only that, we'll get plus that imaginary number and minus that imaginary number. So we'll get two solutions, two different imaginary numbers, and those solutions will also be complex conjugates. So if you had a negative 7 plus 3i over 16, then you'd have negative 7 minus 3i over 16 as the other solution, and those are conjugate solutions. The next case would be having a perfect square that's under here. So let's say something like a 25. That's a perfect square. So we can take the square root and be done with the square root altogether, but it's still going to be plus or minus 5. So we end up with two different solutions, and they're both rational. Okay, and let's say that this is a positive number under here, but it's not a perfect square. So something like 13. So we can't simplify that anymore. We'd end up with negative 7 plus the square root of 13 over 16, and negative 7 minus the square root of 13 over 16. So we do get two different irrational numbers. And so you can see that the b squared minus 4ac is really going to have all the bearing on what kind of solutions we're going to have. Here we want to use the discriminant to determine the number and type of solutions for each of the equations. We're not going to solve, we're just going to tell what we know about the number and type of solutions. So b squared minus 4ac. b squared, that's negative 5 squared, minus 4 times a times c. So negative 5 squared is a positive 25. We have a negative times a negative is going to be positive. 4 times 6 is 24 times another 6 144. That gives us 169. So now we know that the discriminant is a positive number. That means we're going to have real solutions. And it's a perfect square. So we'll have rational numbers because the square root will completely fall out. So two rational solutions. Here, 5x squared plus x plus 2 equals 0. Let's go ahead and take our discriminant expression and start finding out what that is. So b squared, b is 1. 1 squared minus 4 times 5 times 2. So that's 1 minus 4 times 5 is 20 times 2 is 40. That's a negative 39. So we have a negative number under the radicand. That means we're going to have two complex solutions. They'll have imaginaries in them. And then we have 3x squared plus 10x minus 2. Again, the more times you write this, the better off you will be with remembering it. B squared, we'll have 10 squared minus 4 times A times C. This gives me 100. And a negative times a positive times a negative is going to be positive. 4 times 3 is 12 times 2 is 24. That's 124. It's a positive number, but it's not a perfect square. So we're going to end up with a radical still in our solution. So we'll have two irrational real solutions. Now we want to solve these equations. These are the equations that are quadratic in type. So they appear to not be quadratic, but upon further inspection, you can see that they can be written as a quadratic using what we call U substitution. Alright, and this is a multi-step process. You really have to keep on top of this and make sure that when it comes time for you to solve these problems that you complete each of the steps as needed. So starting out, I've got this equation, but one thing I notice is that I have this x squared, and this x to the fourth can be written as x squared squared. Okay, so and just put this in parentheses. Kind of helps your eyes to see what's going on a little bit better. So what we'll do is we see that we have this thing squared minus 15 times the thing minus 16 equals 0. That is quadratic in type. So we can use our U substitution. What we do is we say let U equal the x squared. Now you're going to have that statement. If you don't have that statement, you're more than likely going to get lost in the process of solving these types of equations. Alright, so we've got this, and now we're going to rewrite this equation in terms of U. So if x squared is U, then we replace this with U and we have U squared minus 15 times x squared, we know is U, minus 16 equals 0. Now we see we have a much simpler quadratic equation, and we can solve that. So let's go ahead and start factoring. U minus 16 and U plus 1. And then we're going to take that and solve. U is 16. U is negative 1. Now, a mistake that a lot of students will make at this point is stop, think that they're finished and go on to the next problem. The problem with this is that we had an equation in the beginning where we had x. We need to be solving for x. All we've done is the first half of the problem solving for u. So what we'll do is take this, put it in to the let u equals statement, and solve those equations. So if u is x squared and u is 16, then 16 is x squared. Same with this one, negative 1 is x squared. Now we need to take the square root of both sides of those equations, just solving it using the square root property. And remember, when you put the square root on there, it has to be accompanied with the plus minus sign. So I get x equals plus or minus 4. And here x is plus or minus I. So I have 4 solutions: 4, negative 4, I, and negative I. This next problem, again, looks kind of difficult, but when you step back and look at it a little closer, it actually is quadratic in type. So we're going to take and try and identify what our u is in the problem. Well, always look at the smaller exponent. This is a smaller exponent. If we let u equal a to the 1/3, isn't it true that this is a to the 1/3 squared? Okay, let me write that out. This is a to the 1/3 squared minus 2 times a to the 1/3 equals 3. And when I let u be substituted in for a to the 1/3, I get u squared minus 2u equals 3. Now we have a much simpler quadratic equation that we can solve. I'm going to factor. U is 3. U is negative 1. Okay, remember, you're not finished when you found what u is, because we're solving for a. So we're going to take this, put it back into the let u equals statement, and get 3 equals a to the 1/3. And negative 1 equals a to the 1/3. Now we need to solve these simpler equations. Now it looks a little odd. What would you do to figure out what a is? Just think what the rational exponent means. A to the 1/3 means the cube root of a. And if you had the cube root of a equaling something, you would cube both sides. So we do the same thing. And it makes sense, because when you have an exponent already and you raise that exponent to another exponent, then you're multiplying those exponents. I get a equals 27. And here I'm going to cube both sides again. And I get a equals negative 1. So 2 solutions there.
In this problem, we have 2x plus square root of x minus 3 equals 0. First thing I want to do is identify what our thing is that we're going to let u substitute as. So we're going to write this x as a square root of x squared. And then it's easier to see that we have 2 times something squared plus something minus 3 equals 0. So you let your u equal that square root of x that you're substituting in there. So 2u squared plus u minus 3 equals 0. Factor that, you get 2u and u. Then we want a 3 here, a 1 here, a negative here, plus there. That will give me my positive u in the middle. And so I got u is a negative 3/2, and u is 1. Now we put those into the let statement. So we have negative 3/2 equals the square root of x, and 1 equals the square root of x. We'll square both sides, and that gives me x is 9/4, and of course x is 1 over here. And we do have to check both of those. So I'm going to put 9/4 into the very original problem before you did any operations. 2 times 9/4 plus the square root of 9/4 minus 3 equals 0. So this is 9/2 plus 3/2 minus 3 equals 0. So I have 9/2 plus 3/2 is 12/2, which is 6. 6 minus 3 is 3, and that does not equal 0. So 9/4 is an extraneous solution, does not actually work. Now let's check 1. 2 times 1 plus square root of 1 minus 3 equals 0. And then I'm going to check, 2 plus 1 minus 3 is 0. That's true, it checks out. So x equals 1 is our only viable solution.
Okay, here, I'm not going to completely do this problem for you. I'm just going to start it out. But if we want to talk about this in terms of it being a quadratic in type, you can see we have 2 times something squared minus 7 times that same something plus 6 equals 0. So we're going to let u equal that thing that is linear here and being squared here. Then when you rewrite the equation, you get 2u squared minus 7u plus 6 equals 0. Again, you're going to go ahead and solve, take those, put it into the u, get your solutions. Okay, we have something similar here. I will go ahead and work through this one with you. I have a t to the negative 1 and a t to the negative 2. Isn't it true I could write that as a t to the negative 1 being squared? Because when you raise a power to a power, you multiply the exponents. Yeah, that makes sense. What we're going for is trying to find that thing that we're going to let u equal. So let u equal t to the negative 1. Rewrite the equation in terms of u. Okay, and then we're going to have u plus 7, u minus 6. So u is negative 7 and u is 6. Put that into the let u statement. I have negative 7 equals t to the negative 1, and 6 is t to the negative 1. Now think about how would you get this negative 1 exponent off the t so that the t is completely by itself. If we can raise that to a power of negative 1, then the exponents multiply and it becomes a positive t. So that's the way to go. We would do the same thing on the other side. Negative 7 to the negative 1 is going to be 1 over negative 7, or a lot of books will want you to write where the negative is out front of the entire fraction. Do the same thing here. Exponent of negative 1. We're going to have 1/6 equals t. Right here, again, we're looking for it to be quadratic in type. So this needs to be expressed as 3 square roots of x squared plus 4 square roots of x equals 4. And let's get that put in parentheses so it's a little easier to see. We're going to let u equal the square root of x. Rewrite the equation as 3u squared plus 4u equals 4. Again, I'll let you finish that, put it into the u statement, solve for x. Right, this next problem, definitely there are other ways to solve this, but we're going to go ahead and do substitution, and it does make it actually a little easier to do it with u substitution. We can see easily here it's 9 times something squared minus 30 times something plus 25 equals 0. So we know we're going to let that u equal the 3m plus 2 over m. Rewriting the equation, you see, yes, it's a much simpler equation. And when I go to factor that, it's going to be 3u minus 5 quantity squared. So of course 3u minus 5 equals 0, 3u equals 5, and u is 5/3. So we only have one thing to put back into the let u equal statement, because that was a perfect square trinomial. We have a double solution. So let's go ahead and put that into our let statement. We get 5/3 equals 3m plus 2 over m. And then you see here you have a rational equation or a proportion where you have a fraction equals a fraction. So if you can recall, you can go ahead and cross multiply there. So 5m equals 9m plus 6. That gives me a negative 4m equals 6, and m equals a negative 3/2. Alright, and so only one solution there, and definitely if you saw the other way to go ahead and expand this and multiply through and clear fractions and do everything, this is a much cleaner, quicker way to do the problem. That covers it for this section, so go ahead and try your homework.